Hello and welcome to another episode of Direct Current and Energy.gov podcast. I'm your host, Matt Dozier. Today I want to talk about something a little outside our usual wheelhouse, something that doesn't normally come up in the same conversation as energy. That's beer, more specifically craft beer. The craft brewing industry has become a powerhouse in the beverage world over the past decade, accounting for roughly a quarter of the $100 billion U.S. beer market. As of 2020, there were nearly 9,000 craft breweries across the nation, up from just 1,800 in 2010. Craft beer has seen a wild proliferation of styles over the years, with trends and crazes that rival the fashion world. For craft beer fans, there's no end of discussion about what goes into the beer, things like grain bills, hop varietals, yeast strains. It's a deep, deep rabbit hole. But all this talk about what goes into the beer tends to leave out two key ingredients: water and energy. And that's where we come in. Stay with us for the story behind your favorite craft brew before it ever hits the glass. It's science
for the people.
This is Direct Current.
A good brewery that cares about water use like ours still uses about 4 gallons of water to make every gallon of beer. Some breweries use up to 7 or 8 gallons of water to make 1 gallon of beer. So yeah, it's enormous.
That's Mark.
My name's Mark Fisher. I'm the Director of Operations at Deschutes Brewery.
Deschutes is based in Bend, Oregon. It's one of the biggest craft breweries in the U.S. with nationwide distribution and a devoted following.
We're the 10th largest craft brewer in the country, and we've been around for 33 years.
If your idea of a craft brewer is a couple guys concocting increasingly bitter IPAs in a garage, you're way off. Well, pretty far off anyway. Like I said, this is a huge business these days, and for an operation of Deschutes' size, that means lots and lots and lots of beer.
Deschutes, especially for me, it's a big step up.
Oliver Risto is one of the brewers at Deschutes. He's relatively new there, having worked at a few different breweries in Colorado before this.
A lot of the places that I worked had been more like smaller neighborhood type breweries that are doing less than 5,000 barrels of production a year. And Deschutes is somewhere in the 270,000 barrels a year. So the scale is a lot different.
For reference, a standard keg of beer you'll find in a bar is half a barrel. A keg holds 15.5 gallons of beer, so let me do some quick math here. That's around 8.4 million gallons of beer coming out of the brewery every year.
We do something like 52 to 60 brews a week, which is a lot. Most of the places that I've been before, like if we had 9 in a week, it was like, whoa, it's a pretty busy week. But here, there's really no time to waste. So everyone stays really busy.
The demanding production schedule keeps Oliver and the rest of the Deschutes crew going pretty much nonstop.
We're operating 24/7, so we're around the clock. And our schedule is either 6 p.m. to 6 a.m. or 6 a.m. to 6 p.m. So we work 3 12-hour shifts, 12.5-hour shifts a week. It's kind of fun because you basically come in and like you're either day or grave. And then you have your counterpart who are either grave or day. And you're just kind of handing the shift back off between each other. So you come in, you get to talk to the people who replaced you just 12 hours ago about how everything has been going. You kind of get caught up to speed, and then it's kind of just jumping right in.
I actually caught Oliver right at the end of one of those 12-hour shifts. He was working the day shift. He very patiently put up with my questions as I stood between him and a well-deserved weekend. We talked about what goes into making the beers, which is huge quantities of grain and hops and, of course, water.
You know, it is a very water and energy intensive process. Just the amount of water used would shock most people. Because you think about water just being as like the part of the beer that makes it liquid. Obviously, we use water. When we're brewing, we're putting a bunch of water in the tank and then we're putting grain and hops in there. But I think that people don't realize how much water goes into the rest of it, how much water goes into the cleaning.
Cleaning is super important in brewing because any contamination in a fermentation tank can spoil an entire batch. And when you're producing beer on this scale, with thousands of gallons in a single batch, consistency is key.
It's not terribly hard to brew a good beer one time, but it's very hard to brew a good beer the same every time.
Which brings us to the other missing ingredient I mentioned earlier, and that's, surprise, surprise, energy. There are lots of different ways energy gets used around the brewery, keeping the lights on, powering machinery, but the biggest is heating and cooling the beer at various stages of the brewing process.
So we have very specific temperature parameters that we need to keep things within, and that's a big drain on energy.
So in a large brewery like Deschutes, you've got all this water you need to heat up to a boil, keep it boiling long enough for the grain to break down and release its sugars to create what's called wort, and then cool it way back down before moving on to the next step.
When we're brewing, when we're producing wort, that wort is basically been at or near a boiling temperature for a couple hours. And before we can add yeast to the wort, it has to be cooled down. Sometimes as much as, like, if we're talking the wort has been boiling, it's like at 180 degrees. We have to get it down to, as cool as 50 degrees before we can add yeast, because if it's too hot, the yeast is just going to die.
Yeast is what does the hard work of fermentation. These little microbes eat the sugars in the wort, turning them into alcohol and carbon dioxide. And yeast can be really, really finicky. Go too far below its preferred temperature and fermentation will be too slow. Too far above and it could die, stopping fermentation entirely. So no beer.
So we've got 21,000 gallons of beer that we need to stay at exactly 72 degrees Fahrenheit for exactly 60 hours. And so that is a big drain in terms of energy. It gets even worse when we need to cool the beer down for filtering. So we'll have to take it from 72 degrees and crash it to 31 degrees. And then it has to stay cool really through the rest of the process, all the way through, being cold stored in our warehouse. So regulating temperature, making sure that we're maintaining temperature is probably the second largest drain after water.
At Deschutes, like any big production facility, all that energy and water use tends to create waste. These little glitches where things don't work with perfect efficiency. And sometimes those little glitches can create big opportunities for savings. That's where the Department of Energy's Better Plants program comes in. It's managed by our Advanced Manufacturing Office, and it helps producers of all kinds find ways to identify waste and remedy it, saving energy and reducing costs.
So the Better Plants program is part of a broader Better Buildings initiative, and it's simultaneously both a leadership initiative and a technical assistance initiative. We want to engage all across the industrial community, from manufacturers to water and wastewater treatment agencies and everything in between, to work with them to set and achieve ambitious energy reduction goals, with water reduction goals, waste reduction goals, and we're really trying to focus more and more on these grand challenges around decarbonization.
Eli Levine is the Better Plants program manager. While many of the Better Plants partners are big manufacturers like steel plants and water treatment facilities, Eli said breweries are a natural fit for the program.
Better Plants wants to engage with everyone. Craft breweries make up some of the 250 partners that we have in the program, and there's a lot in making beer that you may not think about when we're sitting back and enjoying a cold brew, but there are opportunities to save money and to be more competitive and improve their bottom line, but also to be smart about how we're using the resources all around us.
For Mark Fisher and Deschutes, striving for better energy and water efficiency is a no-brainer.
Yeah, so we've been with the Better Plants program for 5 or 6 years now, and we joined it because we care about energy. We understand that what we do consumes a lot of energy, and so we want to be good stewards of that. So the DOE has this Better Plants program, and they partner with producers like us to help in managing our energy. And so they offer people, they offer spreadsheets, they offer all kinds of tools that help us do a better job in reducing our energy intensity.
Better Plants partners set their own goals and do their own work to reach them. But having an ally like the Department of Energy on their side in that effort can make a huge difference.
I think it's always true that when you have a reason for doing something, it pushes you harder to do it. And so even during the last few years of some rough times, we've been looking at that goal and wanting to achieve it. And so we're very close to achieving our first goal. And there's something exciting about that. There's something exciting about sharing with our coworkers that we set a goal and we achieved it, and it's helping things out.
So how exactly does a company like Deschutes go about reaching those goals? How do they pinpoint opportunities to save water and energy in the first place? Well, Eli said one of the ways the Department of Energy can help is through another initiative called the Industrial Assessment Centers, or IACs.
There are industrial assessment centers located at universities all across the country. And this is a program that's been around, I think, even a little bit longer than the whole Department of Energy has been around, some 40-something plus years. And it's a really great program that trains undergrad and graduate engineering students to go out and give free energy assessments to small and medium manufacturers, including breweries all around the country. So the IACs to date have conducted over 60 assessments at breweries all around the country, including Deschutes Brewery.
To learn more about how these assessments work, I spoke to Monica Hang.
My name is Monica. Pretty much I started my whole academic career at Oregon State University, and I participated in the INC for, I think, 3 or 4 years. I got hired as an energy analyst. So pretty much what the job entailed was traveling to different kind of medium-sized industrial facilities, like industrial manufacturing facilities, and performing an audit. And we would tour the facility with facility personnel, whether that be like their facilities engineer or just somebody who knew the process really well. And we would go around and take some notes and try to identify kind of their bottlenecks or areas where they could save money on energy.
Monica said she participated in between 25 and 30 energy audits around the Pacific Northwest during her time with the IAC, ranging from lumber yards to water treatment plants to breweries and everything in between. She was actually one of the students who toured Deschutes back in 2019. She said the experience was fascinating, if a little daunting at first.
Oh, yeah, it was super challenging. Really, I didn't know anything about brewing. I didn't know much about the industrial or manufacturing world, but brewing was definitely like super interesting because, it was a whole new process for me. Like, I didn't know how we got from grains to liquor, right? But I remember going to going to breweries in general, but going to Deschutes was really memorable.
Through conversations with brewery staff and observations gathered during their tour, the IAC team pieced together a picture of all the little ways energy and water were going astray.
There was actually like a piece from the Deschutes audit, and it was associated with like bottle washing. And I just remember, we were walking around, and at one point, the tour guide or facility personnel was complaining, like, oh, yeah, there's like water that gets everywhere, and we can only do so many bottles at a time. And seeing all the water on the ground, like, that was an indication for me, like, that's a money saving opportunity.
When Monica and her fellow students toured facilities, those little aha moments were everywhere. She said it felt like being a detective, poking around a scene and looking for telltale signs of waste. So after the tours, the IAC team would compare notes, list out the trouble spots they identified, and deliver the client a report with suggestions on how to fix them. They'd also calculate how much the client could expect to save by following their recommendations. And some of the dollar amounts on these are pretty eye-popping. For Deschutes, the Oregon State IAC team found potential cost savings close to $250,000, with a 41% reduction in utility costs. At some of the other facilities audited by the IAC, estimates range into the millions. That might sound wildly optimistic, but Monica was quick to point out that those numbers are all grounded in real data and thoroughly reviewed.
Occasionally, you would definitely get almost like, that number doesn't seem real, that sort of reaction. But yeah, those calculations were done not just by one person. They're never just done by one person. It's always a collaborative effort. And when we're proposing these opportunities to our clients, we're providing them the assumptions that we made and making it really clear to them that, this is how we got to this number, and this is why it makes sense based off these numbers. Like, even if the number sounds crazy, or even if it's like, holy crap, that's a lot of savings, right?
With the IAC's report in hand and the backing of the Better Plants program, Deschutes has taken big steps to cut back on energy and water usage in recent years. That's mostly come in the form of installing some really impressive new technology, like something Oliver called a heat exchanger, which makes their brewing setup more efficient.
It's kind of like a radiator. It's like a series of metal tubes and shells, and it's got 2 inlets. So you can put your hot wort in one side and then cold water in the other side, and you allow them to kind of pass by each other in the heat exchanger. The wort cools down a lot, so it allows you to kind of achieve your goal of being able to pitch yeast into it. But as a byproduct, the cold water that you're sending in heats up pretty dramatically. So we're able to recapture that water and use that in the next brew without having to heat water up organically. So we save a little energy there.
Another innovation recirculates deoxygenated water that can be used to tweak the alcohol content in a batch of beer.
And that's allowed us to save over 1 million gallons of water a year.
Then there's carbon dioxide, which Deschutes uses to carbonate the beer and pre-treat tanks to keep them free of contamination. But there's one problem. The CO2 arrives at the brewery in the wrong form.
When we get CO2 deliveries, it comes as a liquid because it's a lot denser and easier to transport. But obviously, liquid CO2 really has no benefit for us. We have to use it in its gaseous form.
But Deschutes has turned that problem into an opportunity. Inside the brewery, with all this energy going into boiling huge quantities of water, things can get uncomfortably warm for the brewers.
So we have to heat up the CO2 before we can use it. And we're doing that by supplying hot air that's existing in our production facility naturally, that's making the work environment not good for the employees. And so we'll take the hot air that's in our production facility, use that hot air to vaporize the CO2, and then we're left with a cold air byproduct that we can pump cool air back into the brewery, kind of effectively acting as an AC unit while also getting us the product we need, which is the gaseous CO2.
And not only that, but Oliver said if the temperature in the brewery is comfortable enough, they can redirect that cold air to what's called a glycol chiller, which they use to regulate the temperature of the tanks.
That's kind of a really cool way that we're using technology to still be able to, conduct business as usual while allowing us to kind of find some energy savings and be creative in our problem solving to kind of solve multiple issues at once.
One of the most powerful aspects of the Better Plants program is something that Mark said is already pretty ingrained in the craft beer world, and that's collaboration.
The craft brewing industry is very collaborative, and so for many years, brewers have gotten together and shared best practices around energy use. There's a Brewers Association that most of us are members of. They have a sustainability benchmarking tool, so we can all compare our energy intensity, whether it's water, whether it's electricity or natural gas, against each other. And so we all know where we stand, and then we all share best practices on how to reduce it.
It's not just about doing one thing at one facility. Companies like Deschutes that partner with Better Plants are encouraged to be leaders in their field, sharing energy-saving tips and lessons learned far and wide. And according to Eli Levine, there's also a spirit of healthy competition involved, challenging more and more producers to get in on the savings.
Better Plants really wants to foster the FOMO. We want other companies to say, hey, why aren't we taking advantage of that? Better Plants, it's a voluntary program. There's no cost to participate. And the more companies that we have participating in it, really the better it is for everyone.
For students like Monica Hang that participate in the IACs, there's another dimension to the benefits of the program.
Where I am today is I'm actually at Intel. So I work at Intel now as a facilities engineer, specifically with the liquid industrial waste group.
Monica said the experience she gained through the IAC really helped shape her career.
One thing that I really value in my career is I really value being able to utilize my degree and the knowledge that I've gained, like the technical knowledge specifically. And so when I was looking for positions, that's kind of what I was trying to look for. I was looking for positions that I felt like I could apply myself and could apply everything that the INC has provided me. I really think that my experience at the INC has really prepared me for this position. I don't ever think that I would have gotten this position without that experience.
For Oliver, working at a company that takes sustainability seriously played a big part in his decision to take the job at Deschutes.
It's really nice. It's honestly, I was content at the brewery I was at before this, but kind of knowing where Deschutes stood on the issue and knowing the resources that they had at their disposal, it certainly influenced my decision to take the job here. So it feels good, it's nice to be able to do something that I love and know that I'm doing it close to as responsibly as we can be doing it.
Sustainability isn't just a buzzword for the craft beer industry, which is already feeling the impacts of global warming on some of the very ingredients it depends on. In recent years, wildfires worsened by climate change have ravaged much of the Pacific Northwest and Northern California, one of the most productive regions in the world for growing hops. Increasingly frequent and severe drought and extreme heat events are predicted to have major impacts on the world's barley supply in the coming years.
It's important for us because we recognize that we use a lot of energy to make our products, And we're also very agricultural based in that all our ingredients are grown by farmers that, use Mother Earth to do it. And so we just care about it because it makes sense and we rely on the earth. So we want to make sure we take care of it in all that we do. There's obviously financial benefits to using less energy, which is good, but just caring about the earth and leaving enough for our children when they grow up.
Deschutes is actually named after the Deschutes River, which flows through the brewery's hometown of Bend, Oregon. Mark said that fact isn't lost on the company as it works to reduce its own environmental footprint in the local community as well as on the global scale. And that sense of responsibility and concern for the planet is shared by many of their customers.
Our research has shown that consumers of craft beer do tend to care more about sustainability than other people. So we definitely recognize that our consumers care. And so we would like to continue doing what we're doing because of that.
So next time you raise a glass, pick up a can, or just pass by the beverage aisle in the grocery store, think about where it comes from, the energy, water, and natural resources that go into it. And remember that there are people working hard to make the environmental impact of every pint a little bit lighter. Cheers! That wraps up this episode of Direct Current. Catch more stats and videos on energy and beer in our show notes. For more stories on energy's innovations, impacts, and the people behind it, check out the rest of our episodes at Energy.gov/podcast. Next month, we'll be bringing you a series of episodes on careers in energy. Thank you to Oliver Risto, Mark Fisher, Monica Heng, Eli Levine, and the DOE Better Buildings program for their contributions to this episode. Thanks as well to my colleague Anne-Marie Horowitz for the episode idea, and to our interns, Natalie So and Michaela Tillery. Direct Current is produced by me, Matt Dozier. Sarah Harmon creates original artwork for all of our episodes. This is a production of the U.S. Department of Energy and published from our nation's capital in Washington, D.C. See you next time.